Let's hope everyone's doing well. Let it be known that on this day, January 29th, I'm outside sitting in the quad making this raggedy video. It's probably about 58 degrees. Something else. Anyway, solving quadratic inequality. We talked today about solving linear equalities. Today we're going to turn it up a little bit. So for this particular problem, I'll give you one specific example. Remember, quadratic is the highest degree term. It's 2x squared, for example, plus x. Let's say that's going to be less than 6. Okay. So this is a quadratic in nature. It's an inequality because it's less than, and we're going to talk about how to solve this. Okay. Now, recall that if this were to be an equation, what I would want to do is set it equal to 0. So I'm going to do that here, subtracting 6 for both sides. And what I then have is an entirely trinomial quadratic on the left, which is less than 0 on the right. Okay, now I can work with this, because what I can now do is, again, if it were equal, right, I would factor, right, or try to factor. And that factors nicely as such. And I haven't really done anything with that less than yet, that inequality. Okay, now, what this gives me is two what I would call boundary points. Okay, and my boundary points are going to be the zeros of the factors. Even though it's not equal to 0, I'm going to use those. Okay, so just as always, those two factors give me the zeros, but it's not an equation I'm solving, it's an inequality. So here's what I'm going to do with those two boundary points. Those two boundary points on a number line are going to define 3 regions. Okay, so I have -3 over here, I have 2 over here, right? And so if that's my number line, here are my two boundary points, which I just got, right? -3 and 2 on the number line. And so I got 3 regions, right? I'll call it, for lack of a better word, everything to the left of -3, between -3 and 2, and then region 3 after 2. Okay, so what I'm going to do is I'm going to check numbers in each of those 3 regions, right? So I'm going to take a number less than -3, say -5. So what I'm going to do is I'm going to plug -5 into this inequality here and see if it works. And if that number does work, then every number in that region 1 will also work. So I'll shade in that region to the left of -3. So if I plug -5 back in, I'm going to square it. I'm going to add -5 and subtract 6, right? -5 squared is 25, of course, plus -5, that makes it -5, minus another 6. So all, at the end of the day, I get 25 minus 5, 20, minus another 6, which is 14. Of course, 14 is not less than 0. So what that means is -5, which is somewhere here in region 1, doesn't work, right? Therefore, no number in that region will work. Okay, so I'm not going to shade region 1. Okay, I'm going to take now a number between -3 and 2. So region 1 doesn't work. No number in that region will work, in fact. So I'm now going to take a number in region 2 and check it, see if it works. If it does work, I'm going to shade that region, that being region 2, interval number 2, between -3 and 2. So a nice number in that area is 0, right? And that's easy to check, right? So I'm going to plug that into my inequality, which I believe looks something like this. Oop. X squared, oop, there it is, plus x minus 6 is less than 0. And I'm going to check region number 2 when x equals 0, right? Because that's a nice number between -3 and 2, the two boundary points. Right, so I'm going to plug 0 back in, and I'm going to ask myself, is that less than 0? And of course it is, because -6 is less than 0. Check. All right, so 0 works. Now what that means is that every other point in that region will work. So I know that any number between -3 and 2 will work. Right? Now note that because I'm talking strictly less than, I'm going to open circle at -3 and 2. Okay. Now I'm going to check a number in the 3rd region, and so any number after 2 will suffice. So take 10, for example. I'll check 10, plug that in an inequality. And so I'll check the third region when x is 10. And 10 squared plus 10, again I'm plugging it right back into the original inequality. Is that in fact less than 0? And of course it's not, because 100 plus 10 is 110. Minus 6 is, what, 104. That's not going to make it. All right, so 10 doesn't work, so that means no number after 2 will work. Okay. So the solution set, therefore, region 1 didn't work. Whoops, sorry. Region 3 didn't work, so the solution set is interval number 2. Behind interval number 2 is our solution. And so that solution looks like x is greater than negative 3, but less than 2. Of course, negative 3 and 2 being what I would call our 2 boundary points, all right, which define the 3 regions. The boundary points are the 0 of not the inequality, but the equation. Okay, and we use those to center our analysis about. And we've also been talking about how to write that in a little different way. At interval notation, we start at negative 3, we move all the way up to 2, and that is our interval notation. Okay, so that's how one way we can solve quadratic inequalities. There are other ways, but this is one such way we can do that. All right, here are 2 problems for you to try right now. Oops. How about this? X squared plus 3x is greater than 10. And then I want you to try x squared is less than 4x and plus 21. Okay? So I want you to take a little peeky at those 2 problems. I want you to solve and then write the solution in 2 ways. Okay, that being interval and as an inequality. And then 3, graph the solution. Okay? All right, have fun. Bye-bye.